The classification of discrete time system, so static and dynamic system, and casual and an uncasual system, linear and non-linear system, time variant, time invariant system, FIR and IR system, stable and unstable system. So static and dynamic system. So discrete time system is called static or memoryless system. So it is output at any instant depends upon the inputs in samples at the sample time does not depends upon the past and future of the input. So otherwise the system known as dynamic or have memories. So see this the static and dynamic system. So static means y of n is equal to a x of n. So y of n is equal to a x square of n. Dynamic system they're having the static system and dynamic system. So static is memoryless. Okay. So here the example for memoryless means that doesn't have minus or plus. So minus indicates a past value, plus indicates a future value. So there is no minus or plus. That is, it is called as static. And dynamic means they have the past values also. They have the future values. So that means so see that time depends on past and future. Okay. So this is the values. So they have that. So that's why they call us a dynamic system. So it's a static doesn't have past and past values. So this is memoryless. And next one is cancel and non-cancel. So cancel is x of n, x of n minus 3. So it's a past inputs. So it's a casual. So it has only present and past only, remember. So it is casual. But this system has can depends upon the future inputs. So future means it is non-casual. The system only depends upon current and past values, that is called as casual. Output of the system depends upon the future values or future input, that is called as non-casual. And linear and non-linear system. So linear system is nothing but satisfy the superposition principles. So the system is when it is linear, that is have to satisfy the superposition principle. So what is superposition principle? So the system to be weighted sum of signals should be equal to the corresponding weighted sum of the output of the system. So of the each of the individual input signal, that is superposition principles. Okay, actually system weighted sum of each signals should be equal to the corresponding weighted sum of the output of the system to each of the individual input signals. So this is a equation. So this is how to satisfy that signal. Then that is called as linear and non-linear system. And time invariant system. So time invariant and time variant system. So systems said to be time invariant. The characteristics of this system do not change with time. So that is time invariant. Okay. So the characteristics of the system should not change even time is changed. So that is time invariant. Otherwise, it is time variant. And FIR and IER system. So this is finite impulse response FIR system example. So H of n is equal to impulse response. So this is FIR system example. So 1 2 1 the 1 3 2. So for the n values, so time period. An infinite IER system is an example impulse response, infinite impulse response. This is H of n is equal to a power n u of n. So IER system example. So H of n is equal to a power n u of n. U of n is nothing but that unit step signal. So A of n is equal to a of n. And stable and unstable system. So linear time invariant system. So if you are linear and time invariant system, so system with impulse response H of n is equal to bounded input signal. So H of bounded input sequence to the bounded output sequence, that is called as stable. If the output is unbounded, the system classified is unstable. The input sequence to be bounded output sequence. Okay, they have bounded input and bounded output, that is called a stable system. There is no bounded input, it's unbounded, then that is called as unstable system. Okay, the problem we will see in next videos.